Hey everyone, Eric here, the director of exhibits for Curiodyssey, and we're back in the workshop, but I don't have a build for us today. I know. Before disappointment sets in, let me ask you a question. Have you ever seen water freeze like that right before your eyes? Well, if not, you're definitely going to want to stay tuned for today's experiment because it's a great one. Today we are looking at supercooled water. That's right, it's water that is cooled below freezing but still maintains a liquid state. And this is a great experiment you can definitely try at home with your kids. The materials are very simple because all you need is water. In this version of the experiment, you also need a freezer. A household freezer will do. Now, if you're thinking, that sounds like something I'd like to see, then boom, I got you. Because if you like this video, please help us keep creating ways to experience Curiodyssey from home with a donation today at curiodyssey.org. So, how does this work? Well, let's talk about making some supercooled water. Now, how does one go about supercooling water? Well, as I mentioned, you're going to need water. Now, most versions of this experiment call for water that's somewhat pure, so some say distilled water, but purified drinking water will do, and that's what I have here, so that's what we're going to use. And there's a few different ways to go about this, but as I mentioned earlier, this version of the experiment calls for just a household freezer. So that's what we're going to try. But timing is critical on this. You need to bring the water to a very low temperature, but not so that it freezes solid. So there's a small window to shoot for. So to hedge our bets, I'm also going to be using a few different volumes of water. So I have this purified water, and this purified water, and this purified water. So we're going to be putting these into the freezer. We're going to be laying them on their side. We're going to try to minimize contact with other things in the freezer around them, and we're going to leave them undisturbed for close to 2 hours. I'll probably begin checking at about an hour and 50 minutes or so. And then I'll check for about every 10 or 15 minutes thereafter at regular intervals. And we'll see if the water gets supercooled. Now, how do you tell? Well, the easy way might be to put a thermometer into this water to see if it's below freezing. But there's another way. And that way will generate ice crystals very quickly. Like I said, it's almost instantaneous. Not quite, but you can see them forming right before your eyes. Very cool. So let's go pop these in the freezer and set the clock and get this experiment started. Okay, so I have my waters. They're going into the freezer. Now, our freezer is very full, which is not ideal, but I'm gonna try to pick spots where they kind of minimize contact. They can sit on top of other things, but we'll try to avoid things touching the sides. So in they go and carefully goes, and then we set the timer. Hello! So, I bet you're wondering why we're here.
I'm hot.
Are you? Well, how about some nice cold water to help with that?
La la la.
Like so cold that it might just freeze right in front of us. Like that! What do you think of that? Should we check it out? Okay, I don't know if it's gonna work. I'm gonna go into handheld mode. I'm gonna get the water out, and we're gonna see if it works. Okay, moment of truth. Carefully open the freezer.
Why?
Well, you don't want to jostle the water. Okay, this one may be too far. I'm gonna carefully lift it out. The little one here. Oh, this one's too far. Solid. This one. What about this one? This one's still liquid. Let's take this one. Oh, careful, gentle. Oh no, it went. It just froze. I shook it. Okay, when we're gonna check the big one. Okay, this one just froze right in front of my eyes. So we did it, but we kind of failed to get it up on the counter in time. But we made our ice crystals, so I know it's possible. Let's see what happens with the bigger bottle. There's another way to do this experiment, but let's check that big bottle too.
Yeah.
The good news is you thaw it and you try again. So we'll do that too. I don't want to jostle this because I don't want to nucleate the ice. Okay, close that. Over to the counter. And ready, Ray? Ready? 3, 2, 1. Anything?
Nope.
This one's not ready yet, in other words.
Oh,
It looks like there's some ice crystals, maybe. Oh yeah, it's going. Look, Rye, look. It's going. See the
Ow.
Sorry. See the crystals here? This one kind of went, but not as dramatically. I think it was close, but you can see definite ice crystals in there when I smacked the bottle on the counter. So there you have it. We did do it, but I think we should try again. Do you want to try again and see if we can do it again, Ray?
Mm-hmm.
Maybe we thought. It's a nice hot day today, so it's a good day to try this again. We've thawed our water. We're gonna reset. Put these in here. And we will try one more time and see what happens. If we don't get a great result, I mean, we did get a result last time, but let's try it again. I have a backup plan. Okay, so
Shorty scorty.
let's see how we did on our attempt number 2. We're gonna pull these out.
Okay, guys.
I'm gonna pull them out
Ready?
carefully. This one.
Nice beat.
This one's frozen already. This one already froze, so we have to try the medium one. I'm carefully pulling it out. It's still liquid. All right, right here, do me a favor and bump it on the counter. Oh yeah, there it goes. There it goes. Ice.
Ice crystals.
Ice. Look at that.
Thanks.
Super cooled water. Let's see about the little one. What about the little one? Okay, not a big surprise. The little one froze solid already. Or not solid, but it's got ice crystals already in it. But so that time we had success with our middle size bottle. Look at that, Rye.
Yeah,
see the ice crystals? Just like instant ice. All right, super cooled water experiment version 1. Let's go regroup. Okay, so there you have it. Ice. Just like that from super cooled water. Pretty fascinating, but man, it's a hot day and that bottle had condensation on it. It was kind of hard to see, but you could see the ice crystals form. So I'm wondering, is there a different way to do this experiment where we can see it a little more easily? And the answer is yes. But to do it, I need to gather up some supplies, so I'm gonna go round those up and I'll meet you over at the work table. Okay, so I've rounded up all the supplies for version 2 of the supercooled water experiment. The great news is most of this stuff is regular old household stuff, so you should still be able to try this version of the experiment at home. So let's take a look at what we have here. We have, first of all, some bowls, a smaller glass bowl and a larger glass bowl, one that fits inside the other with a little bit of space between. And then we have a thermometer. This is a meat thermometer, more for higher temperatures, but it does go down below freezing, I think, in Fahrenheit. So we're gonna try to use this to measure our water temperature. Then in this container here, I have salt. Regular old iodized table salt will do. And in this bowl, ice. Then lastly, of course, can't forget some purified water. So we're gonna set this up and try to supercool this water again. Now, if any of you have ever made ice cream before and you've used the method that involves ice and salt, you might be familiar with what we're gonna do here. Basically, we're gonna pack ice around these bowls. So, I'm gonna fill this bowl of ice. And that should do. Next order of business is to take our purified water, fill the inner bowl. So we fill that. Now, this part's critical. We are going to be adding salt to the ice. Now that's going to bring that temperature outside here below freezing. I cannot get any of the salt into this water, so it may be a good idea for me to cover it. I'm going to go get a cover and we'll put that over that container, and then we'll proceed with the salt, just so we don't risk contamination. Now, to sprinkle a little salt into the ice. And like I said, this should lower the temperature in the surrounding area below freezing. Not being very tidy, so it's a good thing I got that cover. You shouldn't need very much, maybe a couple tablespoons is sufficient. All right, there's our salt. I'm gonna put the temperature probe in. Carefully remove this. Temperature probe going in, and we'll keep an eye on where we're at. Right now, thermotemp's reading 69 degrees, so in it goes. Should start to see that number drop. So as you can see here in the corner, temperature on the probe is dropping. So we're gonna keep an eye on that, and what we wanna see is that get below freezing temperature. So we're watching for about 32 degrees Fahrenheit. Okay, so I'm not sure, we may have kind of hit a wall here. Temperature's been holding at 37 degrees, so it's cooled considerably, but we're still hovering 5 degrees above freezing point, which is not good in terms of supercooling. So what I might do is do a slight reset on and actually reload with some more ice and salt and see if I can continue to get the temperature to drop. So we're gonna try that next. Okay, so we're back and ready for a reset on this. So the big difference here is my container. I'm gonna be using this fancy glass, which I actually bought a long time ago in the Curiodyssey shop. I don't think they have these anymore, too bad, because it's really a fun glass, but you should visit the Curiodyssey shop online. Anyway, this glass is great because it's a nice thin wall. It's almost like a piece of lab glass, like a beaker, so I have higher hopes. Also, smaller in diameter, so I'm gonna fill this with less water. We'll have less thermal mass to chill down. And so I'm gonna fill up the bowl with ice now. So we're all set up with the ice. Set the extra aside. We have our purified water. And I'm trying to be careful to not contaminate this water. We need the inside to be clean. So in goes the purified water, maybe about half full. And then cover back on. Now it's time to add the salt. Again, I think about 2 to 3 tablespoons should be sufficient. I'm just gonna eyeball it, sprinkle a bunch over the ice. That should be sufficient. All right, now carefully I'm gonna remove the cover, place the probe. I've been trying to keep the probe clean so we don't introduce any contaminants into the water. So in goes the probe. We'll see what that starts to read. Temperature's already dropping on the gauge, so that's good. All right, so I'm gonna monitor this and we'll check back as we get closer to our freezing point. Okay, so look at this. We've gotten lower than the temperature we were at before. We're at 33 degrees. That's 1 degree above freezing. Okay, so the thermometer just kicked over to some mode. Again, I'm using a meat thermometer, so it's really meant to detect high temperatures, not below freezing temperatures. So I have to assume that maybe right now it's reading freezing temp. So I'm gonna wait a little bit longer here, and then we are gonna try to initiate the reaction. So I'm gonna just leave the camera rolling and we'll see what happens. Now it's just the waiting game. It's been close to 5 minutes, and since my thermometer isn't reading below freezing, all I have to go on here is time. So I'm nervous, I have to say. I'm hoping, my fingers are crossed that I have supercooled this water. So in about 20 more seconds, I'm gonna try to propagate the reaction of ice formation. And to do that, I need to find for myself a little sliver of ice that I can drop in to the container. So I have a perfect sliver here. And first thing I'm gonna do is remove the probe. I've got the camera on it in case the agitation of removing the probe alone sets off the reaction, but I'm gonna just carefully pull the probe. Still looks very, very much like a liquid. So, the moment of truth. And I tell you, I am nervous because I hope this works. So, here is catalyzing ice in supercooled water, hopefully in 3, 2, 1. Doesn't look very good. Let's try a bigger piece. Here we go again. Oh! It might be happening. I think it's happening. The water is freezing. There it goes. Look at that. Ice propagation. It's happening! Woo! Oh man, I was nervous. We did it. We made supercooled water just with ice and salt. I would give it a minute to let the ice crystals form, but here, I'm gonna pull the camera out, do a handheld shot, give you a better look. Look at that. Just like that. Ice right before your eyes. You can see the crystalline structures in there. Let's take the glass out. And boom. That was awesome. Awesome. There it is, my friends, supercooled water. All right, let's go back over to the workbench, process what we've seen here, and have a little discussion before we close out for the day. Thanks. Okay. Woo! I tell you, the reason I was so nervous is because I had a lot of time invested in that experiment. The first time I ran that with the previous setup and the bigger container of water in the middle, it took a long time to chill it down, even down to 34 degrees Fahrenheit. So with that earlier attempt and this one, I had a bunch of time invested in this experiment, but it is possible. I've learned though that having enough ice and salt so that you're not fighting such an uphill battle trying to chill down the thermal mass of your container of water is pretty important. So, little lesson learned there. But that was exciting to see. I mean, I have to say, it's such a fascinating phenomenon. It's really interesting. So, how exactly does that happen? Well, it's something called nucleation. So by putting that little chip of ice into my supercooled water, I was initiating the nucleation of ice crystals. And what that is I'm starting to let the molecules arrange into little clusters. And those clusters mimic the crystalline structure of the solid form of the ice. So you can create nucleation through various means, and as you saw with the water bottle that we put in the freezer, you can do it through shock and actually initiate the nucleation that way. In this case, we actually put a chip of ice into the supercooled water, which started the process, which then propagated throughout the container of water. So that was pretty fun. I mean, really an interesting phenomena. It's just, it's mesmerizing that things like that can happen. So I hope you all had as much fun as I did. That was really cool. And thanks for watching. Please help us keep creating science, exhibits, and zoo programs you can enjoy at home with a donation today at Curiodyssey.org. Thanks again. We'll see you next time.